So in that, what was our numerical? So our problem was that reinforced. We have to determine the reinforcement requirement for a rectangular beam. Okay, the width of beam was given to us. The width of beam was 300 mm. Okay, and the depth of section was 500 mm. The ultimate bending moment was given. So mu is given 80 kilonewton meter. Torsional moment is 40 kilonewton meter. So value of P it is also given. Then shear force, factored shear force, it is 70 kilonewton. This was also given. M15 and Fe415, it is the grade of the concrete is given to us. So this was the given data. From the total depth, that is 500, we have calculated effective depth first. Okay, up till now we have solved, up to which point we have solved the problem, that I am recalling to you. Uh, so you can also confirm that. So overall depth, it was 500 mm given to us. So we have assumed 25 mm clear cover, 10 mm diameter for the stirrups, and 20 mm our main bar diameter. Okay, and we have calculated our effective depth, and it was 455 mm. Then after that, we have calculated the equivalent bending moment, that is ME1. We have already gone through the formula of this ME1. Okay, what was the formula for ME1? It is Mu plus MT. We have already calculated this value ME1, and it is already Mu plus MT. Okay, and this value is works out to be, after solving this, 142.74. This value we have calculated 142.74 kilonewton meter, and for this value now we have taken what, check for depth. Okay, we have taken the check for depth, and check for depth कसा घेतला, you have equated this moment to this bending moment to moment of resistance, that is our formula. What it is, 0.138 fck bd square. Okay, so by using this we have calculated the depth, the required depth, and required depth, it was, you can see the required depth what we have calculated, it was greater than the our depth which we have provided. So finally we have provided the overall depth of 600 mm. Okay, and the effective depth, and our effective depth, it was 555 mm. Okay, this was our last step of the calculation. Up to this point we have solved the problem. Okay, we have provided our what we can say, overall depth and effective depth. Okay, so now we will move further to solve the problem. So the further thing is that, so the size of section, so the size of section, what is the size? It is 300 mm by 600 mm. Okay, now calculate the steel. We know the bending moment. Okay, so we will calculate the steel reinforcement. So here steel reinforcement, steel reinforcement. So how to calculate the steel reinforcement? It is AST is equal to, you know the formula, 0.5 FCK BD divided by FY in bracket 1 minus under root 1 minus 4.6 mu upon FCK BD square. Okay. So just put the formulas, sorry, put the values in the formula. So it is 0.5 into, I think M15 is there. Please check the grade whether I have taken the correct value or not. Then B is 300. Then our effective depth is 5. It is 5, 5, 5. It is triple 5 divided by Fy is 415, and here in the bracket it is 1 minus square root of 1 minus 4.6. Our MU value is 142 point. What was the value? I need to check that. 142.74. 142.74 into 10 to the power 6 whole divided by FCK is again 15 into B is 300 into D square, that is 555 square. To solve this and let me know the value of area of steel. To check the answer, 826.088 mm square. So we have assumed 20 mm bar diameter, right? So calculate the number of bars now. If we assume 20 mm bar diameter and calculate the number of bars. So here number of bars. How many bars are required? So here 826.088 divided by 5 by 4 into 20 square. So let me know the answer please. 2.63. Okay, so 2.63 which we can round up it to 3 numbers. Okay, so we are going to provide 3 bars of 20 mm diameter. So calculate now AST provided. Okay, AST provided. So we are going to provide 3 bars, each of bar diameter 20 mm. Okay, how many students are there? 20. Coming back to the problem, it is 942 mm square. AST provided. Okay, AST provided it is 942 mm square. So now after this calculation, see this is now reinforcement. प्रॉब्लेम लक्षात घ्या काय केलंय आपण इथं व्हॉट वी हॅव डन वी हॅव फर्स्ट सी दे हॅव गिवन इथपर्यंत मी तुम्हाला सांगतो काय केलंय नीट लक्ष द्या द प्रॉब्लेम वॉज आणि एवढा एकच व्हरायटीचा प्रॉब्लेम आहे या युनिटमध्ये एवढा प्रॉब्लेम एक तुम्ही सॉल्व्ह केला की हा युनिटच संपला याच्यामध्ये व्हरायटीज नाही दुसरी सो व्हॉट आय वॉन्ट टू टेल यू दॅट in the problem they have given you some dimensions of the beam, then bending moment is given to you, twisting moment is given to you, that is torsion or twisting moment you can call it, and your shear force is given to you. So what we have you have done initially, from the given overall depth, some overall depth is given to you, that is 600 mm, 500 mm, 400 mm, whatever it may be. In this problem 500 mm is your depth. What is the depth? It is overall depth. From overall depth we have calculated the effective depth. Now we have solved number of problems. I think you are clear with the concept of overall depth and effective depth. Still anybody is having the problem, you can call me or WhatsApp me. I will tell you individually. Okay, because I have repeated this so many times. What is the difference between overall depth and effective depth? So from overall depth we have calculated effective depth. After that we have calculated the equivalent bending moment. So equivalent bending moment is ME1. It is the notation, and it can be calculated as MU plus MT. So again, the formula of MU is already no formula. Sorry, not formula. MU, the value of MU is already given in the problem. Some value is given. That is the bending moment. MT is the twisting moment. Okay, MT. So that value we have calculated by using the formula. That formula I have already written in the previous lecture, and also it is given in the IS code also. So there is no need to by heart that formula. From that we have calculated the value of MT, and we have added both the values, and we get the ME1, total equivalent bending moment. Okay. To that total equivalent bending moment, we have take the check for depth. And simple it is. If the required depth is less than our provided depth, then it is safe. And if the required depth is greater than the depth we have provided, then it is unsafe. So in our case it comes unsafe. आतापर्यंत आपलं सगळं सेफच आलेलं आहे आपण डिझाईन करताना, पण आज पहिल्यांदा अनसेफ आलं. सो अनसेफ आल्यानंतर काय करणार? सो when it comes unsafe, then we have changed our depth. We have provided higher depth. ओके अकॉर्डिंग टू आता डी रिक्वायर्डची व्हॅल्यू तुम्हाला माहित झाली सर डी रिक्वायर्ड पेक्षा जास्त डेप्थ तुम्ही प्रोव्हाइड करा सो इट विल बी ऑटोमॅटिकली सेफ okay so we have done that instead of 500 we have provided the overall depth 600 आणि एवढं झाल्यानंतर आपण काय केलं वी हॅव कॅल्क्युलेटेड एरिया ऑफ स्टील फॉर दॅट ME1 व्हॅल्यू ती ME1 ची व्हॅल्यू किती आली होती 142 पॉइंट समथिंग 74 or somewhat so for that we have provided the AST area of steel that is our reinforcement and that area of steel is we have provided 3 number of bars each of bar diameter 20 okay just wait हॅलो सर हा लेक्चर चालू आहे माझं अर्जंट आहे का काय हा मग तू मेल आलेले आहेत की सगळ्यांची सर करेक्शनचे कुणाचं फक्त मेल राहिले तेवढं बघा सगळ्याची तुम्हाला मला मेल आलेले मग बघितलं नाहीत का तुम्ही मेल हा मग त्यांच्या मेल नुसार त्यांचे चेंजेस करून घ्या त्यांचे मेल ठेवा ना आपल्याजवळ आणि काय मेल आला म्हणजे त्याचा रेकॉर्डच आहे ना तुमच्याकडे त्यानुसार चेंजेस करून घ्या आणि करून टाका हा फक्त ते जसंच त्यांनी सांगितलं त्या सब्जेक्ट टीचरनी काय चेंज त्याप्रमाणेच करा आणि करून टाका काय अडचण नाही काय जास्त काही नाही दोघं चौघांचं काय तर त्यांनी दिलेत करेक्शन ओके हा so now coming back to the problem so we have calculated AST 3 bars of 20 okay so I hope now up till this point the numerical is clear to you now from here onwards okay now we have calculated area of steel for the bending moment so now we will calculate the equivalent shear okay equivalent shear next is the equivalent shear okay so how do we calculate this equivalent shear so it is calculated as VE is equal to VU plus 1.6 TU upon V okay VE is equal to it is given in clause number 41.3.1 page number 75 okay we have already discussed this I think if you open your ICE code you go to page number 75 you will get this formula VE is equal to VU plus 1.6 TU by B okay so VE is equal to VU plus 1.6 TU by B okay this formula it is given in the IS code clause number 40.4 and page number I think 75 okay this is given on page number 75 please note it down so if you refer that you will get this formula okay so now put all the values and we will get the equivalent shear okay so VE is equal to what is the value of VU the value of VU is 70 kilonewton it is given to us plus 1.6 is the constant into TU what is the value of TU 40 kilonewton meter and B is the width of the section 0.3 so if you solve this you will get the value of equivalent shear and let me know the answer for the equivalent shear 283.33 okay it is 283.33 kilonewton okay so this is our equivalent shear okay now calculate the equivalent shear stress okay so equivalent shear stress tau VE equivalent shear stress tau VE is equal to it is equivalent shear okay, divided by BD it is equivalent shear divided by BD okay. Now calculate this value it is 283.33 into 10 to the power 3 divided by your 300 into 555 these 300 into this is 555 So therefore tau VE is equal to, okay, it is 1.7 Newton per mm square. Okay. बघा आता जनरली आपण काय करतो, when we got the nominal shear stress, see we have designed the other beams also in the previous units. Normally when we calculate this shear stress, what we do, we calculate permissible shear stress. Now this is the nominal or you can say equivalent shear stress. म्हणजे काय, this shear stress is getting developed in that structure. Now, according to IS code, we will check that what is the permissible shear stress, and if our developed shear stress is less than permissible shear stress, then there will be no need of shear reinforcement. And if this developed shear stress is greater than the permissible shear stress, which is given by the IS code, आणि IS code मध्ये तुम्हाला ते कुठं मिळणार permissible shear stress, तर in table number 19. Okay, so accordingly we will decide that whether shear reinforcement is required or not required. But generally you follow one thumb rule: in the case of beams, shear reinforcement is always required. And how do we meet the condition of shear reinforcement? Shear reinforcement means we are providing the stirrups in the beam and column. स्टिरप्स म्हणजे जर तुम्ही साईटवर गेलात तर आपल्या भाषेत म्हणजे साईटवरच्या भाषेत त्याला मिस्त्री किंवा गवंडीशी बोललात तर ते तुम्हाला रिंगा म्हणून सांगतील. साईटवरती शब्द आहे रिंगा. Okay, so that is, those are nothing but stirrups. So mostly in the case of beams and columns, stirrups are 100% required, and in the case of slabs, stirrups are not required because slabs are, most of the time slabs are safe in the shear. And even though if some slab fail in shear, that is while designing the slab, if we observe that the slab is failing in shear, then what we normally do, we increase the depth of the slab, but we don't provide the stirrups in the slab. Okay, but we always provide stirrups in the beams and columns. So remember these things. So now here what is our equivalent shear stress tau VE? It is 1.7 MPa. Okay, now we will move to our IS code and we will see that the maximum shear stress, and then we will calculate the permissible shear stress. Okay, so now here table number 19. Okay, before going to table number 19, here I want to show you one more thing. Generally it is safe, but still additional as a knowledge you can keep it with you. See, here it is given table number 20, and what is the heading? Maximum shear stress tau C max. Okay, and still we are using table number 19. Okay, now what is the use of this table number 20? Now see, for M15 is our grade of concrete. What is the value? The value is 2.5. Means what? आता तुमची टाऊची व्हॅल्यू किती आली आहे? टाऊची व्हॅल्यू आली आहे 1.7. ओके, आणि मॅक्सिमम शिअर स्ट्रेस टाऊ सी मॅक्स, टाऊ सी मॅक्स ची व्हॅल्यू किती आलेली आहे? इथे दिलेली आहे. सो टाऊ सी मॅक्स ची व्हॅल्यू इट इज गिवन ॲज 2.5. सी, आय एम रिपीटिंग वन्स अगेन. In numerical we got this value. Okay, this value is 1.7 equivalent shear stress, and here you can see your maximum shear stress is 2.5. So what does it say? Says that, see, if your equivalent shear stress, that is this 1.7, it comes less than this your maximum value. Okay, maximum value. So there is no need to revise the section. No need to revise the section. Are you getting my point? Revise the section means what? What is our section? It is 300 by 600 now. We have provided the size of our section is 300 by 600. जर हा तुमचा जो इक्विव्हॅलंट शियर स्ट्रेस आलेला आहे 1.7, हाई जर व्हॅल्यू ही मॅक्सिमम जी आपल्याला व्हॅल्यू दिली ना टाऊ सी मॅक्स 2.5 पेक्षा जर ग्रेटर असला असता इफ दिस 1.7 right now we are having this value. If this tau v value instead of 1.7, now suppose this value is 2.7, imagine that, suppose your tau v is 2.7 instead of this 1.7, then this value of 2.7 is greater than this maximum value 2.5. So this is not acceptable. Okay, this is not acceptable. It means that this section is not acceptable. So you have to revise the entire calculation by changing the dimensions of the section. This is the meaning of this. Okay, so first we will do this. So here we know the value 2.5. So here I can write, if I come over here into the whiteboard, so here I can write from from table number 20, page number, I don't remember the page, I think it may be 74, 75, you understand things. Table number 20, remember this. Okay, tau c max, it is 2.5 MPa. So your tau VE, that is the equivalent shear stress, is less than tau c max. So here you can write no need to revise the section. नो नीड टू रिवाइज द सेक्शन. म्हणजे हे जो काय आपण सेक्शन प्रोव्हाइड केलेला आहे 300/600 चा, तर हा सेक्शन तुम्हाला बदलायची गरज नाही. देयर इज नो नीड टू रिवाइज दिस सेक्शन विच यू हॅव प्रोव्हाइडेड राईट नाव 300 mm by 600 mm. Okay, and why there is no need to revise the section? Because your maximum permissible shear value is 2.5 and your equivalent value is 1.7, which is less. वाईस वर्सा जर केस असली असती, समजा की 2.5 अलाउड आहे समजा आणि तुमची व्हॅल्यू टाऊ व्ही आला असतो 2.7, तर 100% तुम्हाला पहिल्यापासून कॅल्क्युलेशन करावं लागलं असतं. यू हॅव टू रिवाइज द सेक्शन इन दॅट केस. ओके, so this is about the section revision. So now there is no need to revise the section, so our section is perfect now, 300/600. Now again we will move to the IS code. Okay, sorry, IS code here. So now here you can see table number 19. As usual, we have used this table many times. You know that how to use this table now. Okay, so our grade is M15 grade. For which value we want it? It is for 1.7. Okay, so here you can see this. You need to do the interpolation between these two values. Okay. So for 1.5 it is 0.68. For 1.5, what is the value? It is 0.68 is the value of tau c. And for 1.75, the value is 0.71, and you want the value, and you want it for 1.7. So for 1.7, what is the value? Do the interpolation and calculate the value and let me know the value. Okay, and this is your design shear strength, tau c permissible. So write down this so that we will move to the whiteboard. So please calculate the value, let me know the answer. And please check the grade of concrete. It is M15 or M20. I think M15 is given. Maybe in last lecture somebody has corrected me over that. So हे सगळे फॉर्म्युले इथं आहेत बघा, MT वगैरे on page number 75. Everything is there. And this table number is page number 73, I think. Okay, so on page number 73, this is the table M15. हा बघा याच्यात काय जे दिलेलं आहे त्यानुसार व्हॅल्यू फाइंड आउट करा. We required for 1.7. Let me know the permissible shear stress. Calculate the permissible shear stress. Hello. हा चेंजेस पुन्हा कुणाचे सगळ्याचे मेल आलेत का बघितलंय का तुम्ही? कुणाचा मेल राहिला असं कोण आहे का? साठे सरांचा मेल मी यासिन सरांना फोन लावा ना, त्यांना विचारा ना ती मार्क आहेत का, तसं मेल करा म्हणा. मेल सगळ्याचा येऊ दे सर, त्यांना ज्यांचं राहिलंय त्यांना मेल करायला. नाही नाही, ग्रुपवर तर सगळे बघत नाहीत. काय होतंय यासिन सर वगैरे कसं आहे, एक तर ती लांब आहे, तुझ्या त्यांनी रिस्पॉन्सिबिलिटी पण घेणार नाहीत ना. तुम्ही प्रत्येकाचा मेल येऊ द्या आपल्याला, त्यांना सांगा तुम्हाला काय प्रॉब्लेम नसेल तर नो करेक्शन म्हणून मेल करा म्हणावं. मेल घ्या, मेल आल्याशिवाय घेऊ नका. तुमच्याकडे 5-6 सब्जेक्ट आहेत ना, त्या सब्जेक्ट टीचरचा मेल येऊ द्या. हा त्यांना पुढे नाही पाठवलं तर कॉल लावा त्यांना, पाठव म्हणा मेल, आत्ताच्या आत्ता पाठव, करेक्शन नसलं मोबाईलवरनं पाठव म्हणायचं 2 मिनिटात मेल. ठीक. So now Tausi permissible. Why you are taking too much time now to calculate the value? Please calculate it. What is the permissible value? Anybody? See, I don't have the what we can say calculator with me. Also, I don't have the answer of this question with me. So unless and until you solve it, I will not move further. So it is 0.56656. एवढी कमी येते का व्हॅल्यू? हॅव यू चेक द व्हॅल्यूज? 0.656 is the right answer. Okay. So the others please check the answers. I don't know which answer is correct or wrong. 0.8. Okay. Anybody else? So two different answers are there with us. 0.65 and 0.8. Please confirm the answers once again. Just a simple interpolation is there. पण अजून एकदा चेक करा. 0.65 and 0.8. Which answer is correct? Let me know. See, if you don't give the answers quickly, then this problem may go on for next 1 hour also. If you make a time pass like this, not a tedious calculation, just a interpolation, simple interpolation. Why it is taking too much time, I don't know. Please, others, please give the answer. Which answer is correct? At least you tell 0.65, 0.8. Both of you also, roll number 2, roll number 11. Please recheck the calculation. Both of you are getting different answers. So if the same answer is there, I could have taken the answer immediately. But please check it now. Let me know. So now 0.704. So here I can write as per table number 19. Okay, it is not page number 75. I think so. Page number 73 maybe. You check the page number, write that accordingly. Tau C permissible. It is 0.704 Newton per mm square. Okay. So here what is happening now? Your tau V is greater than tau C. So shear reinforcement is required. So we have already assumed the 10 mm diameter for the stirrup. So we will provide two leg the 10 mm diameter stirrups. Okay. So here your tau V is greater than tau C permissible. Okay. So here which says us that shear reinforcement is required. Shear reinforcement is required. या दोन्ही मधला डिफरन्स समजून घ्या. these two things. हा जो पहिला चेक होता फ्रॉम टेबल नंबर 20 पेज नंबर 73 अगेन tau c max This shows you that there is no need to revise the section. म्हणजे section तोच ठेवायचा का section तुम्हाला बदलावा लागणार आहे. Okay, this comes from this table number 20, page number 73. These two values, tau c max and your tau v. These two decide that. And once it is confirmed that there is no revision of the section, then you go to table number 19 again and calculate the tau c permissible value. And now if your permissible value is less than your actual value, then you should provide shear reinforcement. Okay, if this tau c permissible it is less, or you can say that tau v is greater, so the developed stress is greater than the permissible stress, so the reinforcement is required. Okay, in this way you clear your logic, not don't by heart the thing. So now once it is confirmed that the shear reinforcement is required, okay, once you come to know that, okay, now the shear reinforcement is required, so what will be your next step? Now provide the shear reinforcement. If it is required, we have to provide. So here we can say provide two leg 10 mm diameter stirrups. Okay, two legged 10 mm diameter stirrups. Now if we provide this stirrup, then calculate the area of stirrups now. The area of steel for the stirrups. So area of steel for the stirrup ASV is equal to, it is two legged stirrup. If I 4 into 10 square. Calculate this. What is 157.07? Okay, 157.07. Now see, if you look at your beam. Okay, now if you look at your beam, if I draw here the diagram, so now this is your beam. Okay, now this is the stirrups which you have provided inside the beam.
हेलो सर, भोसले सर,
हाँ
1 मिनट जरा. हेलो
हाँ
सर.
हाँ बोलिए सर.
See, the students who haven't yet filled that NAC form, no, please do it. It is very urgent. जो लोग अभी तक वो फॉर्म नहीं भरे, रोल नंबर 39, 47, 56, 59, 63, 67 एंड 68. मैं आपको एक बार फिर बोलता हूँ, रोल नंबर 39, 47, 56, 59, 63, 67, 68. वो यहाँ नहीं है तो आप कोई भी उनको बोल के याद दिलाओ. गौरव टांग है क्या? उसको बोल दो जल्दी से भरने के लिए. और जो लोग आधार कार्ड नहीं दिए यूनिवर्सिटी डाटा में, आपको कोविड का इंजेक्शन नहीं मिलने वाला है. जल्दी से आप आधार कार्ड नंबर अपना भर दो. उसमें बोल दो अपने सबको, सब दोस्तों को. ठीक है सर, थैंक यू.
Okay. So now, suppose now this is the beam, and here you have provided those stirrups like this. This is the stirrup. So up till now what we have done, we have provided this bar diameter. So these bars we have designed. Here we have provided 3 bars of 20 mm. Okay. So these are our bars. These are our 3 bars of 20 mm. And this is our stirrup. This is our stirrup of 10 mm diameter. Okay. But to hold this stirrup and this bar, we require to provide the bars at the top also. ओके, म्हणजे आपल्याला काय करावं लागेल, इथं टॉपला पण काहीतरी कमीत कमी 2 बार टाकावे लागतील. का तर त्याच्याशिवाय हे स्टिरप्स तुम्ही बसवणार कसं? हा रेक्टँगल तुम्हाला दिसतो ना. इफ यू आर ऑब्झर्विंग दिस रेक्टँगल रेग्युलर स्टिरप्स आउटसाइड, ठीक आहे, you have designed these bars at the bottom, so you will provide the stirrups like this, but these stirrups will be fit there only and only when there you provide the bars at the top also. Okay, so as per the IS code, for the earthquake, 13920. Okay, so here minimum 2 bars of 12 mm should be provided. These are very important things. I am telling you the clauses from IS codes also, other than IS 456 2000. So this clause is not given in IS 456 2000, but as per the for the design of earthquake resisting structure, if you want to design a structure which is earthquake proof, okay, then minimum 2 bars of 12 mm diameter you should provide at the top. Minimum it is 10 mm actually. As per the code, what code says that you should provide at least 2 bars of 10 mm diameter at the top. But here for our safer side, instead of 10 mm diameter, we will go for 12 mm diameter. Okay. So I hope now you understood these things. So here I will write also provide for earthquake proof resistant structure. Okay, provide 2 bars of 12 mm diameter at top. So हे काय दोन 12 mm चे बार आपण डिझाइन केलेले नाहीयेत, काहीही नाहीये. These bars are not designed like these bars. 3 bars of 20 mm diameter हे आपण डिझाइन केलेले. We have designed these bars, but these bars we have provided as per the norms given by the Indian standard codes for earthquake resisting proof design. Okay, so here the 2 bars of 12 mm diameter we need to provide at the top. Now see, I will draw the correct diagram. So now we are going to provide the transverse reinforcement. Now if you go to the IS code, and if you see the transverse reinforcement, the provisions for transverse reinforcement here, see, this is the transverse reinforcement. Longitudinal reinforcement आपण already provide केलेली आहे. This is the formula. This is, you can see, longitudinal reinforcement, and it is ME1 is equal to MU plus MT. So you have already provided the longitudinal reinforcement, that is 3 bars of 20 mm. Now the transverse reinforcement we have designed. We need to design, and there we have chosen the two-legged 10 mm diameter stirrups. Okay, now spacing. Transverse reinforcement. Now we need to calculate the spacing of that by using this formula and this formula also. Okay, so this is the, you can see, two-legged stirrups. Okay, when the longitudinal bars shall have an area crossover ASB given by. So this is the formula. So in this formula, you see, if you carefully observe, you will see the term. So now it is, I am not able to zoom it. See if I can zoom it. Okay. So now here in this formula, you can see the terms. If you observe carefully, this is the transverse reinforcement. You will see the term B1 D1. Okay. Here you can see B1 is one term is there and D1 term is there. So now we will see what is this B1 and what is this D1. All the other terms are known to you. Okay. So we will see that first. What is B1 and D1? So here if you see, if you come over here, here you can see the meaning of that is given. What is B1 and what is D1? This is B1 D1. Center to center distance between the corner bars in the direction of width. Okay, हे लक्षात ठेवा. कुठून कुठलं डिस्टन्स आहे? Center to center distance between the corner bars in the direction of width is B1. This is B1. What is D1? Center to center distance between the corner bars in the direction of depth is D1. Okay. So now we will move to calculate this B1 and D1 first, and then we will take this formula. Okay. So this formula we are going to use. while solving the problem. Okay, calculating the transverse reinforcement. So now again we will move to the whiteboard. So here now transverse reinforcement spacing. Okay, so I will write here the transverse reinforcement. Calculate the value of B1 and D1. Now to calculate the value of B1 and D1 we need to draw the neat diagram. So see, this is your rectangular beam. What are the dimensions? So this total dimension and this total dimension, it is 300 by 600. This is 300 and this is 600. Okay. Now where the bars are provided, if you see, first I will draw the stirrups inside it and then we will draw the bars. This is the stirrups which is provided. This is the stirrup of 10 mm diameter. And now where the bars are provided, so bars are provided like this here. Okay, here the 3 bars of 20 mm. And here at the top 2 bars of 12 mm. And what is our clear cover? Our clear cover is 25 mm. That also I will show over here. This is our clear cover. This is the clear cover. This is also clear cover. Okay. So it is 25 mm. 25 mm. 25 mm. So आता B1 म्हणजे काय आणि D1 म्हणजे काय, that you need to understand. So B1 means what? Now observe carefully from where to where I am taking the distance. This green. Okay. So now see, from center of this bar. Okay. From center of this bar to the center of this. This is called as B1. Center to center distance of the bars in the direction of the middle. Okay. So this is B1. Center to center distance. And what is D1? So from the center of this bar to the center of this bar in the direction of that, this distance is nothing but it is D1. Okay, this is B1 and D1. Okay, I hope now you cleared with this B1 and D1. So now I want to calculate these things. So here I will start. So therefore B1 is equal to, so B1 means total width is 300 minus now see this total is 300. So from that 300 I will minus this cover 25. Okay, I have to minus this cover which is 25 mm. मला या सेंटर पाशी जायचं आहे. Okay, I want to go at the center of this bar. So from this 300 I should minus this cover. This is 25. Go for the higher diameter bars. Okay, which bar you have designed, sir? See, the question is why we are taking B1 at the bottom, why we are not taking at the top. This is the question. So the simple answer to this is, see the greater bar diameter first. So out of these two, greater bar diameter is at the bottom. Second thing is, we have designed these bars, 3 bars of 20 diameter. We have not designed these 2 bars of 12 diameter. These bars we have provided for two purposes. First purpose is to anchor this stirrup. म्हणजे तुम्ही खेळायला एखादी गोष्ट अडकवता ना, खेळायला फ्रेम अडकवता का नाही, अनलेस अँड अंटिल you hammered that into the wall, you cannot hang anything to it. The same role is performed by these two bars. Okay, to hang, to provide the anchorage to the stirrups. First thing. Second thing is, these two bars are provided for the ductility purpose, to enhance the ductility of the structure, to enhance the its performance against the earthquake. Okay, and it is given by the IS code of earthquake by designing the earthquake resisting proof structure. So these bars, we have not designed these bars. Please understand this. We have provided these bars as per the norms given in the IS code for the earthquake resistance proof design. म्हणजे हे बार एक तर आपण डिझाईन केले नाहीत, आपण मग डिझाईन केलेले बार कुठलेच हे बार आहेत, 3 bars of 20 diameter. This is the first thing. Second thing is that this bars is having higher diameter, that is 20 which is greater than these 12 and uh, correct. So that is why we are providing the we are taking the width at these bars. Okay. So now, so I have minus this 25. Coming back to the problem, this total is 300. I hope now you got your answer. Still, if you are having any query, you can ask me later on. Okay. So now this is 300. So we will minus this cover 25 Then we have to minus this bar also. That is 10 Bar means what? It is stirrup. The diameter of the stirrups is 10 Then we come inside. Then here is the bar of 20 Okay. Now we have to go to center of that bar. So we have to minus half of bar diameter again. Okay. Half of bar diameter again. So similar thing we need to do on the other side also. So if I write over here 300, that is total, okay, minus 25 is the cover from this side, or I will write it separately so it will be easier to understand it. So from this 300 I have to minus first this 25, okay, plus 10 this 10 plus 20 by 2 एका साइडचं झालं हे, plus second side also 25 plus 10 plus 25. Okay, so therefore V1 is equal to, मी दाखवलं बघा V1 कुठून कुठलं डिस्टन्स आहे इथे डायग्राम मध्ये. डिस्टन्स कॅल्क्युलेट करायचे फक्त तुम्हाला, ते तुम्ही कसंही कॅल्क्युलेट करा चालतं. किंवा सिम्पली आय कॅन राईट ओव्हर हियर 300 मायनस दोन साइडला आहे म्हणून 2 into it is 25. Okay, it is 25 plus 10 plus 25. So now if you solve, you will get the value of V1. V1 is 210 So roll number 65, I hope now you have got your answer. Okay, why we are not taking breadth on the top side, that is the reason. Okay, so 210 answer correct. V1 value. Now similarly we are going to calculate the D1. Now how do we calculate the D1? So D1 is equal to total depth is 600 minus here. First we will consider the bottom side. Bottom side ला cover किती आहे? Clear cover 25 plus stirrup चा bar किती आहे? 10 चा आहे plus बॉटमच्या सेंटरच्या बारला जायचंय, तर बॉटमच्या सेंटरचा बारचा डायमीटर आहे 20 by 2. So now plus again see from the top, the clear cover is 25 plus again the stirrup bar diameter is 10 plus the top bar diameter is 12 by 2. So the topmost bars are of 12 diameter. Okay. So you can solve this. D1 is equal to is 5, 1, 4 and so now we have got this value B1 and D1. Now we will calculate this transverse reinforcement. Okay. Now we will calculate the transverse reinforcement. So the formula for that we can write over here first. So ASB is equal to TU into SB divided by B1 D1.87 FY. Okay, so ASB is equal to ASB is equal to so from the IS code you can see the formula and you can write over here. Is TU into SB divided by B1 D1.87 FY. So it is TU into SB divided by B1 into D1 into 0.87 FY plus the VUSB 2.5 D1.87 FY. VUSB 2.5 D1 again 0.87 FY. Just you need to put the values over here now. Okay. Just you need to put the values. So therefore ASB, what is the value of ASB? We have already calculated it. What was the value? We have taken two legged 10 mm diameter stirrups. So 157.07 some answer you have calculated. Please check the value. Okay. So now TU twisting moment, how much it is given? 40, 50. It is 40. Twisting moment is 40. Yes, so 40 into 10 raised to 6 into SB as it is. SB as it is. Divided by B1. What was the value of B1? I think 210. D1 514. Until this is 0.87 into 415. Value of F1 plus VU. What was the value of VU given to us? 70. Okay. So it is 70 into 10 to the power 3 into SV divided by 2.5 into D1. D1 is 514 into 0.87 into 415. Okay. So this is the numerical. Now you need to find out the value of SV. So solve this problem and find out the value of SV spacing. So if I take the SV common, then it will become 157.07 is equal to, this first bracket will be 40 into 10 raised to 6 divided by 210 into 514 into 0.87 into 415 plus 70 into 10 to the power 3 divided by 2.5 into 514 into 0.87 into 415, and if I take the SB common, I will write the SB here. SB means spacing of stirrups. So therefore, SB is equal to, calculate the spacing now, 133.44. Good, okay. So it is 133.44 mm, which we can round it up to 130 mm center to center. Okay, but we have to also follow the clause of minimum transverse reinforcement. Okay, so the transverse reinforcement shall not be less than, this is the formula I will write over here. So the transverse reinforcement, the transverse reinforcement shall not be, the transverse reinforcement shall not be less than, shall not be less than, what is the value? So we have to write the formula. It is ASV is equal to tau VE minus tau CV into SV. So ASV is equal to tau VE minus tau CV into SV divided by it is 0.87 FY. So 0.87 FY. Now all these values are known to you. Only the SV is unknown. So again calculate the spacing. So this is 157.07, which is equal to tau V किती आलं होतं आपलं 1.7 I think. Okay, minus this tau C 0.74 का काहीतरी calculate केलं होतं तुम्ही maybe. बघा, you keep the as it is values. I am taking here the approximate values. So 1.7 minus 0.74. B is already known to you. B is 300. SB is as it is divided by 0.87 into 415. The answer is 189.79. So it is 189.79 mm. So we can round up this value to 185 mm. Okay. So now see which is the lesser of these two. Okay. So SV किती मिळते? SV तुम्हाला इथं 185 mm. Okay. But if you go to the IS code, page number 48, clause number 26.5.1.7 in that A. Okay, कुठं सांगतो? Again, page number 48, clause number 26.5.1.7a. Okay, so in that some provisions are additional provisions are given for the spacing of the stirrups. Okay, so that also we should consider over here. So again we will move to page number 48 in the IS code. Okay, so page number 48 in IS 456 2000. So we will come out of this zoom first. Let us do it 100. Okay, so we have to go to page number 48. So this is 48. Now here you can see, I will zoom this once again. So this is the clause number 26.5.1.7. Okay, here you can see the transverse reinforcement for the torsion shall be a rectangular closed stirrup placed perpendicular to the axis of the member. The spacing of the stirrup shall not be exceeds the least of. Okay, so it is x1 first thing, x1 plus y1 by 4 second, and in no case it is 300 mm. Okay, in no case it is 300 mm, where x1 and y1 are respectively the short and longer dimensions of the stirrups. आता x1 काय किंवा y1 काय we will see here only, so that you will not get confused. Okay, so now suppose here I will draw our beam. So this is the beam section. So in this beam now I will draw the stirrups. So this is the stirrups. See, this is our stirrup. So now as you know, this distance, this is 300 mm. This total it is 600 mm. Depth total किती है 600 है. Okay, this is known to you. So what is x1 and what is y1 now? So x1 means the horizontal distance center to center of stirrups. म्हणजे stirrupचा हा जो center point आहे इथला, तो इथला center point. हे जे horizontal distance आहे stirrups मधलं, this is nothing but the x1 center to center distance x1. So properly if I show you over here, so this distance center to center distance, this is nothing but this is x1. Okay, and what is y1? So this vertical center to center distance, this vertical center to center distance, this is nothing but your y1. Okay, previously b1 d1 ला आपण काय केलं होतं? For b1 d1 we have taken from the center to center of bars. Okay, म्हणजे बारचा डायमीटर घेऊन आपण सेंटर टू सेंटर घेतलं होतं. Now in this case it is center to center of stirrups. Okay, so I hope now this is clear to you. So now we will move once again to our whiteboard for the further calculations. Okay, so you can write now, as per the code, as per IS code, the spacing should not exceed, okay, x1 plus y1 by 4 and 300 mm. So I will write here, as per IS 456-2000, okay, clause number 26.5.1.7a, page number 48. Okay. The spacing should not exceed the following. Okay. So now in our case we will calculate x1 y1 now. So काय असणार x1 y1? This is the stirrup. This is the beam. I will draw the stirrup once again. This is the stirrup. So now we want x1 and y1. 300. This total is 600 and clear cover is 25 mm. Okay. So x1 is equal to, what is the value of x1? It is 300 minus 25 minus, इकडचं 25 minus होणार या बाजूचं, minus 25 minus half of this bar, half of 10 by 2 minus half of bar diameter म्हणजे 10 by 2. हे एका साइडनी झालं, असं काय होणार आहे ते दोन्ही साइडनी येणार. ओके, so in this way it will come from the both the sides. So again it is minus 25 and minus 10 by 2. So simply you can write x1 is equal to 300 minus 2 into, also you can write 25 minus 10 by 2. So let me know the answer. What is the value of x1? तेवढ्यात मी y1 लिहितो पुढं. y1 is equal to what? It is 600 minus 2 into 25 minus 10 by 2. Let me know the values. This 230 and 530. So this x1 is 230 mm and y1 is 530 mm. So therefore, spacing x1. What is the value of x1? It is 230 mm center to center. The second thing is x1 plus y1 divided by 4, which is equal to, okay, 240, 240. Take it as 240. Okay. So now if it is 240, then you keep this value as 240. Just 1 minute. Hello? हाँ. बरं बरं. आता माझ्या लेक्चरमध्ये मी थर्ड इयर वर मुलांना इन्स्ट्रक्शन दिलंय, देशमुख सरांनी पण येऊन सांगितलंय. मग आता करतो म्हणते मुलं, सांगतो, बघतो कसं होते, करून घेतो. आता इथे लेक्चर मध्ये पण इन्स्ट्रक्शन देतोय. हो हो सर, हो मॅडम. So 240 mm, and now what is y1? 540 mm. Okay, so this is 540. So accordingly you write it now. Accordingly you do it x1 plus y1 and this thing. So x1 plus y1 by 4. Do it fast. 240 plus 540 divided by 4. It is equal to 195. Okay. So 195 mm center to center. It is equal to 195 mm center to center. So now here you can see x1 is there, x1 plus y1 by 4 is also there. Now what is the last thing? Last thing is, in no case, okay, in no case it should be what? It should be 300 mm center to center, in no case. Okay. So now if you see over here, what we have considered now, x1 y1, x1 plus y1 by 4, and in no case it is 300 mm. And what are our previous spacings? These are our previous spacings. First is 185 mm center to center, and the second thing was we have calculated 130 mm center to center. So how many values are there with us now? 5 values are there with us now. Okay, so how many? First is 130 mm, second value is here 185 mm, third value is 240 mm, fourth value is 195 mm, and fifth value is 300 mm. So out of these three, only 130 mm value is less. Okay, 130 value is less, so we can provide these stirrups now. So last line, So this is the last part. So last line should be, you should write provide. See, you can see it right here. Provide provide two leg 10 mm diameter stirrups, 10 mm diameter stirrups about 130 mm center to center. Okay, about 130 mm center to center. So this is our final, we can say, the reinforcement. Okay, so after that we are going to draw the reinforcement details. Okay, so to draw the reinforcement details, we will draw it on the cross section. So first what we will do, we will draw beam, cross section of the beam. So this is our cross section of the beam. Okay, this is the cross section of the beam. So in this, draw the stirrups inside this. So this is the stirrups. Okay, by keeping the clear cover of 25 mm from each side. So now after the stirrups, we will provide the bars. So here our three bars are there of 20 mm diameter, first, second, third. So these three bars are of 20 mm diameter, and at top again two bars will be there of 12 mm diameter. So these are the two bars at the corners which is having 12 mm diameter. Okay. So now if you name this, okay, so these are the two bars of 12 mm diameter, two bars of 12 mm diameter, then three bars, then here you can see these are the three bars. You can say that these three bars, what we have designed, are for that ME1 equivalent moment, and these are the three bars of 20 mm diameter. And lastly, the stirrup. This is the stirrup, and it is two leg, two leg, 10 mm diameter, about 130 mm center to center. The cross sections of the beams are already known. So this is the variety, only single variety of the problem here. Okay, there is no any other variety or any such we can say twist in the numericals or anything will be there. This is the only one type of problem which can be asked. Okay, so now very simple problem. In unit number 6, there is only one problem. This problem is, in that problem, everything will be given to you: bending moment, twisting moment, then your shear force, and they told you to design the beam. Okay, so this is the procedure how we are going to deal with this for the longitudinal reinforcement as well as for the transverse reinforcement. Okay, so I hope now you understood the things clearly for the unit number 6. This is the only just one variety of problem in this. Okay, so in the next lecture we will start with the next unit, that is design of columns. And in design of columns also, in the next unit also, basically two types of numericals are there. First is the design of the column, uh, that basically refers to design, setting out the dimensions and the diameter of the column, and then providing the steel in the column. And second type of problem is calculating the load carrying capacity of the column. Okay, So only two types of varieties are there in the next unit. That unit we will cover in next lecture.